Hello guys, welcome to Cloud Tech. So today we are going to discuss Capgemini Java developer interview. Here we are going to touch upon topics like Java, Spring, Spring Boot, microservices, and Docker. The years of experience is 3 years, and the level of difficulty is intermediate. So at the end of this video, we are also going to look at two Java 8 programs. So watch till the end to understand all the theoretical questions along with the programs. So the first question that was asked to the candidate is explain the purpose of @Autowire annotation in Spring or Spring Boot, and also provide an example of how Autowire annotation is used. So Autowire is used to do automatic wiring. So if one class needs bean of other class, in that case we use Autowire. So let's have a look at the example. Here we have user service class, and user service needs user repository to work correctly. In that case, what we do, we autowire our user repository within user service class. So here what is going to happen, our Spring or Spring Boot application is going to create the instance of user repository and give it to our user service class. So we just have to do one more thing. We have to mark this thing as @service. So this will tell that while creating the bean of user service, we need user repository bean, and before the instance of user service is created, user repository will be created and will be injected into the user service. While using Spring, just you have to make sure that you use this app config class where you provide @configuration and @component scan. So this component scan tells I want to scan com.example package, and I want to find all the beans or all the stereotypes like service, like @component that are present, and create a bean out of them and auto-wire them in the specific classes. Now, this is how your @autowire works. You can also explain the type of auto wires by type, by name. So let's move to the next question. Explain the role of an API gateway in microservices architecture. Here, API gateway is very important. Consider there are three, four microservices, microservice 1, 2, 3, and 4, and they are running on different IP addresses. We cannot share the IP address of each microservice with the client. So there comes an API gateway. So this IP address of API gateway, we share it with the client, and it is responsibility of API gateway to communicate with all the microservices. So let's see how the flow works. The flow works this way. Whenever client makes a request, it first goes to your API gateway. Always it goes to your API gateway, and API gateway is in charge of that request, and based on the request endpoint, it decides which microservice to pass this request to. For example, this endpoint belongs to microservice 1. API gateway knows that this request should go to microservice 1, and it passes to M1. Similarly, if API gateway knows it should go to microservice 2, then it will send that request to microservice 2. Now, to include API gateway, or to make your microservice, one of your microservice as API gateway, you need to add this dependency to your pom.xml. So Spring Cloud Starter Gateway. This is a dependency. If you add this dependency, your API gateway will be added to your microservice application. What are some of the features of API gateway? Some of the features are request routing that we just saw, and aggregation. Load balancing. So consider you have two instances of one microservice, or consider order microservice. There are two instances of order microservice. Then how the load will be balanced between instance 1 and instance 2. That is taken care by your API gateway. You can also perform authentication and authorization. These types of things can be performed in your API gateway. CORS handling, cross-origin resource sharing, is a common error if you have worked in IT industry. CORS is a common error, and this configuration for CORS can also be handled in your API gateway. Rate limiting and throttling can also be handled in your API gateway. The rate limiting is where consider only one guy is making thousands of requests to your microservices. Then we need to limit the rate of request that is coming from single IP. Because if I allocate all my resources to only one IP address, or if only one guy is making a lot of requests, then I have to limit the rate. In that case, rate limiting logic can also be put in your API gateway. And then you can throttle the request. Throttle in the sense all the coming requests won't be served. Some requests will be throttled. So that logic can be put in API gateway. Let's get to the next question. Give examples of commonly used Spring Boot starters. So this is a very important question. Spring Boot starters are a set of convenient dependency descriptors. So here, the whole idea is if you want to design a REST API, then you don't have to specify all the jars that are required to design a REST API application. You just give the starter dependency. For example, Spring Boot Starter Web is a dependency. If you want to design REST APIs, then you can use Spring Boot Starter Web. If you want to add data JPA, then you can use Spring Boot Starter Data JPA. In this case, all the dependencies that are required to make our application JPA compliant and to communicate with the database will automatically be added when we add this starter dependency. If you want to add starter security, then you can use Spring Boot Starter Security. If you want to add a starter test, if you want to test your application, unit test your application, then you can add Spring Boot starter test. So the whole concept is you don't have to add individual jars. You have to just make sure that you add starter dependency, and it is responsibility of starter dependency to include all the required jars along with their versions and to make sure all the jars are compatible with each other. So Spring Boot Starter is a very nice concept, and you can explain this concept to the interviewer. Let's get to the next question. What is Docker and how can it be used in the context of microservices? So Docker is a platform for developing, shipping, and running application in containers. So Docker is a very lightweight platform. And if you are dealing with containers, then Docker is a platform which will help you to build, ship, develop, and run your containers. So consider you have a Spring Boot application. In that Spring Boot application, if you want to Dockerize your application, then the first thing you need is your Docker file. A Docker file is where you specify which version of JDK you want, what is the volume, what is the entry point. So you have to Dockerize your application, and the whole purpose of Docker file is to build the image. An image is nothing but your blueprint for the container. So whenever you want to run that container, you take the image and then you create a container out of that image. So once you create a Docker file, the next thing to do is build the image. So to build the image, you do docker build -t is your tag and then your name of the application and current directory. The current directory is where this command will look for the Docker file and will build the image. So after running this command, I'll have a image with the name your web app, and this image then you can push it to your Docker repository. If you don't want to push this to the Docker repository, but create a container out of it, then you can use this image to create a container. So to run a container, Docker run -p, then port number 8080 and your application or your image name. So what it will do, it will check if your image is present locally. If the image is not present locally, it will go to the Docker Hub or Docker repository, and then it will download that image to your local machine. And once the image is available, it will cache the image to your local repository, and then it will start the container. Once the container is started, now you can hit the API of your application and it will start serving all the requests. The follow-up question that was asked is, what is Docker Compose? A Docker Compose is a tool for defining and running multi-container Docker application. In the above example, we ran only one container. But if you want to deal with multiple containers, in that case, to orchestrate this, Docker Compose is a tool that is used to run multi-container Docker application. So generally, your application does not have only one container. So it is combination of multiple services, and each service is run in a separate container. And to orchestrate all this, we can use Docker Compose. Kubernetes is also there, but as the question specifies, Docker Compose, so we can explain about Docker Compose. Let's get to the next question. What does Spring Boot support? How does Spring Boot support the development of RESTful web services? This is very important for intermediate level experience. So you have to explain the flow. What are the advantages of using Spring Boot when you want to design RESTful web services? Um, Spring Boot uses Spring MVC. It is built over Spring MVC model view controller to help support RESTful web services. So there is something called as embedded containers, where your Spring Boot application has containers, embedded containers like Tomcat and Jetty. So you don't need external web application server to host your application. It is embedded in your Spring Boot application. You can Spring Boot provides request mapping based on the request type, whether it is get, post, put, and delete. These types of request mapping are provided by Spring Boot, which makes it pretty easy to specify which kind of request we want. Content negotiation, where if client wants content either in XML format or in the JSON format, then client can specify produces and consumes attribute, and based on the produces and consumes attribute, the content that will be passed will either be JSON or will be XML. There is something called as request and response handling. So if the client is making a request with the help of JSON, then using this annotation at the request body, that JSON will be bind to the request in the object, and a response entity is where the response will be sent back to the client in the specified format. So the flow looks like this. You can explain this flow using one of the examples. For example, Postman is any client. So Postman makes a request, or any client from Chrome browser makes a request to the controller. From controller, the request goes to service. From service, the request goes to repository. Repository reads the data from database, and once the data is read, the request comes back to repository, to service, to controller, and the response is sent back to the client. So this is how the whole flow works. You can explain this flow to the interviewer. So our next question is, what is Spring Boot DevTools and how does it enhance the development experience? So generally what happens whenever we are developing any Spring Boot application, then we don't hit the logic, or we are not able to write the correct logic in our first go. So Spring Boot DevTools is a tool which will help us correct this problem. So when you add Spring Boot DevTools in your application, then it does automatic restart and live reload support. So automatic restart is where whenever you make any changes to the file in your class path, in that case, your server will be automatically restarted. You don't have to go again restart and then hit the request. It will be automatically restarted by DevTools, and all those changes will be available for you as a developer. And there is something called as live reload support. In live reload support, if you're using a web browser, then your web page will be automatically refreshed whenever there is any change. This live reload will refresh the web page and load the resources from the latest changes. So that is known as Spring Boot. That is about Spring Boot DevTools. You can specify about automatic restart and live reload support. Let's get to the next question. How do you handle communication between microservices? Compare synchronous and asynchronous communication. So as we know, microservices is a set of services. There are multiple small services, and to accomplish one goal, they have to communicate with each other. So there are two types of communication. One is synchronous communication and one is asynchronous communication. So synchronous communication is where client makes a request to a microservice and then client waits for the response. So in this case, until the microservice 2 sends back the response to the microservice 1 will be in blocked state. So this is what is known as synchronous communication, where the client waits until the server responds. So this typically happens with the help of HTTP, REST, or RPC, remote procedure call, or GraphQL. So there are certain advantages of this. It is very simple to implement and it is easy to debug. But there is one disadvantage to this, is where your client has to wait until the server responds back. So client is blocked completely until the server responds back with the response. So this is known as synchronous communication. The other type of communication is asynchronous communication. Asynchronous communication is where your client sends a message and does not wait for the response. The client sends a message and does not wait for the response, and the server in turn processes and then responds back with the response. So this can be achieved. Asynchronous communication involves sending messages between microservices without waiting for an immediate response. So this is often achieved using message queue or using a RabbitMQ, Apache Kafka, or event buses. So you can explain about these two communication, synchronous communication and asynchronous communication. So the advantages of asynchronous communication is loose coupling and resilience. Even the other service is down, then your first service is not blocked because we are not waiting for an immediate response. These are the advantages of asynchronous communication. But the disadvantage is added complexity. As we saw, this is simple synchronous communication. Asynchronous communication has some complexity. You have to add message queue, you have to add Kafka or event bus, and then you have to deal with messages when you want asynchronous communication. Let's get to the next question. What is service discovery in microservices? So service discovery is used to register one microservice from another microservice. So consider your application has 10 microservices. Then you cannot add the address of all the 10 microservices in each microservice. What we do, we create an index where all microservices will register themselves in that index. And whenever we want any of the microservice, we go to the index and we ask for the address of a microservice, and this index provides us the address and the port where that microservice is running. So this is known as service discovery. We are trying to discover a service. So there are two portions to this. The first portion is known as client, and the second portion is known as server. So we use Netflix Eureka for service discovery. So there is one server, but there are multiple clients. So consider there is one Eureka server, and your 10 microservices will register with this Eureka server. So all the 10 microservices will be your Eureka client, and there will be only one microservice which will be your Eureka server. So what do you want to do to make a Eureka client? You want to add this dependency to your microservice, Spring Cloud Starter Netflix Eureka client. Then in the application properties, you need to add these two properties, and your class, your Spring Boot application class, should enable Eureka client. So this makes your microservice as a Eureka client, and whenever you start this microservice, it will register with the Eureka server. Now, how do you make a Eureka server? You add this Netflix Eureka server, and you add this annotation, enable Eureka server to your Spring Boot application. And then once client and server both are started, to test your service discovery, you can hit this HTTP localhost 8761. So it will show you all the microservices that are registered with your service discovery or Eureka server. That is about service discovery. Let's move to the next question. How do you handle database transaction in microservice environment? This is one of the complex questions. You can answer this, but generally for 2 to 3 years, this question is not asked. And even if it is asked, then they don't expect very thorough answer to this question. Okay, so we use Saga pattern to handle database transaction in microservice environment. So a Saga is a sequence of local transaction. As we know, microservice is distributed. So whenever something is distributed, then handling transaction becomes difficult, and uh, we need to take a set of local transactions, and we need to use Saga pattern. What this do? Each local transaction updates the database and publishes a message or event to trigger the next local transaction in the Saga. So there are two types of Saga: choreography based Saga and orchestration based Saga. So you have to answer this. We use Saga pattern for database transaction management in microservice environment. And there are two types of Saga pattern: choreography Saga pattern and orchestration based Saga pattern. Let's get to the next question. Explain functional interfaces and what are some of the available functional interfaces in Java. So functional interface is where you have only one abstract method in your interface, and it is annotated with @functional interface. So even if you don't annotate with @functional interface, it is still a functional interface. But if you annotate this, then there is added advantage. If you try to add one more method which is abstract, then the compiler won't allow adding one more abstract method to this. So there are various functional interfaces, but to name few of them, Runnable is one interface, comparator, consumer, then there is predicate, there is by predicate, there is function, there is by function. So you can name the functional interfaces according to your capabilities or whatever functional interfaces you know. Okay, now there were two Java 8 questions which were asked. The first one of them is you are given a string, and from that string, you need to count the vowels using Java 8 functionality. So let's see. There's a class known as vowels finder. There's an input string. Hello Java 8 vowel example. So the first thing that we want to understand is vowels are A, E, I, O, U. So A, E, I, O, U. And I've written all this in small case. So the first thing I'll do is I'll convert my string to a small case or lowercase. So input string dot to lowercase. Now, as I converted this string to lowercase, I can easily compare the vowels with the lowercase string. So that is my first step. Next, I'll take all the vowels in a list of character. Each vowel is a character. So list of character. Now to count the vowels, what I'll do, I'll take my lowercase string. I'll take chars out of it. So char is your int stream. Then I'll try to map to object, and then I'll filter. What I'll filter? I'll check if my lowercase string contains all the character from my list, vowels list. So vowels list has this character, and if it contains after it finds all the vowels, I'll take the count out of it. So this will give me vowels count, and then I'll print it. So two things to keep in mind: lowercase string and list of character to store the vowel, and then this logic. Now next program is a bit difficult as compared to this one. So in this program, what we have to do is we have to write a program in Java 8, and that is the entity known as book. Book contains title, author, year, and price. Now we are given four statements. Print the titles of book published after 2000. So here we have to compare year, calculate the total price of all the books, find the book with the highest price, and create a new list with books priced less than $40. So we'll see all this in our program. So let's go and see in a Java 8 program. First, we create a book entity and a book model class, and then we write all these instance variables. We also provide a constructor, and we set all the instance variable title, author, year, and price. Then we provide a getter setter. This standard. Then we write a toString method. In toString, we write all the information, or we print the information about the object. So here, nothing special. Now we create a books list, and in books we add several books. For example, we added books of 2014, 2008, and 1999 with various prices. Now, our first thing is print the titles of book published after 2000. This is pretty simple. We filter, and we filter using year, and we see all the books which are published after 2000. And then we map title, and then we print all the titles. Okay, so this is the first statement. Calculate the total price of all books. So here what we do, we take a stream, books.stream, we map to double, and we take get price using method reference, and then we sum it. So summing it is very simple. You get the total price of all the books in your list, and you present the total price, or you print the total price. The next thing is most expensive book. The most expensive book is we need to find the book with the maximum price. We use books.stream max, and we max takes your comparator. So comparator is where we compare two books. We provide book 1 and book 2. And what we want to compare? We want to compare prices of two books. And we compare the prices, And if we don't find the book with maximum price, then we return none. And most expensive book is most expensive book, the variable that we get, or the book that we get. If you want to just print price, you can use dot get price. Now the last one is create a new list with books price less than 40. So books.stream filter, we will take the price and we will filter all the books which are less than $40, and then we will collect using collectors.toList, and then print using for each. So this is the end of interview, and we will keep on bringing such interviews. Just make sure whenever you attend interview, you send your questions to jobreadytrainings22.com. So this will help our community to get more understanding about the process of companies. Thank you guys for watching.